Ramananda sir, are you there? Yeah. Sir, please unmute yourself.
Good afternoon.
Yes, sir. Let me introduce you, sir, to the participants. So we are having with us Professor H. Ramananda Singh. He is professor and HOD in the Department of Business Administration, Assam University, Silchar. With 24 years of teaching experience and 2 years of industry experience, Professor Ramananda Singh's area of interest has been general management, marketing management, and quantitative techniques. He is an alumnus of Banaras Hindu University and Lucknow University. He had been continual in teaching research methods and quantitative techniques since long. Professor Ramananda has 32 numbers of papers publications in referred journals, 9 publications in edited books, etc., and couple of dozens of national international seminar presentations. Apart from academics, he had been the director of UGC HRDC, formerly known as Academic Staff College, Manipur University, for 5 years, from 2014 to 2019. Today, his topic of deliberation will be on parametric test analysis, interpretation with examples. He has already given his 2 sessions in the last FDP that was held in August. So we are again welcoming sir in this session. Sir, the session is yours. You can start.
Good afternoon, everybody. So, Dr. Divisity, shall I start?
Yes, sir, you can start.
So, good afternoon, everybody. And I've been given the opportunity of sharing with you the little knowledge that I have regarding the parametric statistics on t-testing. I don't know much. Actually, I'm in the field of management, and whatever the statistical techniques which are relevant to our management, I have been learning. I've been learning from research scholars, I've been learning from my friends, I've been learning from the seniors, and I have them compiled them together so that it may be suitable for our audience. So whatever little thing I know, let us share with us, that I'll be sharing with you. And during the interaction time, I may be learning from you also. So the learning process goes on. Sometimes we have to unlearn, then we have to learn again. Earlier, we used to calculate manually. Now, with the coming of so many software, we have started switching over to software packages. So today, we'll not be discussing the theoretical aspect, but we'll be discussing how the data is being analyzed using parametric statistics. So let me share the slide. Do you think Dr. Vicky is there?
Yeah, Vicky is there, sir.
So, Vicky, good afternoon. I believe that you'll be helping us, helping me today regarding the technical problem. Yeah. Screen is not coming.
Screen is visible, sir.
But I'm not okay. Wait. This thing has come up.
Vicky ji, are you there?
Yes, sir. Yes, sir. Yes, sir.
Please help sir to.
Yes.
Whether my screen is coming up, sharing screen.
Sir, your screen is visible, sir.
The PPT.
PPT is not, sir.
I'm not.
So do one thing, no, sir? Like you just click on the share button, sir. Please, once again. First,
Okay,
you stop your sharing your screen, sir.
Okay.
Now you, sir, click on the share button, please. No, sir, no, not entire screen, sir. You just click on the share.
Okay. Stop sharing.
Stop sharing. Click on share. Go to the advanced.
Okay.
Then, sir, PowerPoint adds a virtual background.
But it's not coming.
R has to open the PowerPoint at first, I guess.
I have opened already. Okay. It's open.
Open, sir.
Okay.
So this is an advanced option, no? Basic advanced.
But I have done
Yes, sir.
that.
Visible, visible, visible,
Visible,
sir.
sir.
Visible.
But what about this screen, large screen? It should be.
Normal distribution, sir. They're showing the normal distribution slide.
And this one, this screen of your platform, where to hide this one? Okay, now I'm reducing it. Okay.
Yes, sir. Visible, sir.
It is visible now. Okay. Now, is it visible now, Vicky?
Yes, sir. Yes, sir. Absolutely, sir.
Okay. Okay, the topic which was assigned to me is parametric statistical technique. So is it visible and the sound is clear?
Yes, sir. Yes, sir.
So my dear friend, the topic that was assigned to me is one portion, some portion, a portion of a parametric statistical technique. For analyzing the data, there are two types of statistical technique. One is parametric and one is non-parametric. And the parametric statistical techniques are those techniques which rely on quantitative data. And the non-parametric statistics are those data, which rely on the non-metric data. There is data collected on nominal scale and ordinal scale. But these parametric statistical techniques are those the techniques which rely on those that are collected on ratio scale and interval scale. And for these parametric statistics, there is a need for assumption that the data are distributed normally. So the distribution data should be normal. But in the case of non-parametric statistics, such assumption is not needed. Now, as I just mentioned that this technique is based on those data collected on metric scales, that is interval scale and ratio scale. I will come into that again later on. Now, parametric statistics techniques are t-test, one-way ANOVA, two-way ANOVA, three-way ANOVA, one-way ANCOVA, two-way ANCOVA, three-way ANCOVA, trend analysis, then correlation analysis, regression analysis, canonical correlation, factor analysis, discriminant analysis. But in this particular program of 5 days, we'll be covering t-test, one-way ANOVA, two-way ANOVA, and then correlation analysis, regression analysis, factor analysis, discriminant analysis in the next coming sessions. And I'll be covering only t-test because here in the t-test, we'll be discussing 3 cases. One sample, 2 sample, and a pair sample, and they will consume 2 hours. And discussing all the remaining will be discussed in the remaining session by the different resource person. Now, where exactly this testing fits in the entire research process is that after you identify the research problem, then after you review the literature, after making the sampling design, then after collecting the data, what happens is that you have to assemble the data. Then bringing the data into order, you have to make a tabulation, categorize like male, female, rural, urban. Categorization should be done. After that, you have to find you have to summarize the data with the help of arithmetic, mean, median, mode, standard deviation. Then after that, you'll be selecting the appropriate tools. Appropriate tools for what? Suppose, so if you want to examine the stress among the male and female teachers, whether there is a significant difference in the stress level of male teacher and female teacher in Assam, or is there any difference in the score of anxiety among the male teacher and female teacher during the COVID period? Is there any significant difference or not? Then depending upon these conditions, what is the analytical technique intended to do? Scales in which the data are measured, parametric or non-parametric, number of variables to be analyzed, dependence, independent, number of samples to be analyzed. Depending on this, you'll be selecting the various tests available. Various tests available here. Depending upon the conditions, you'll be selecting which test is more appropriate. Today, what are the conditions for t-test? I will be discussing that. for what are conditions, but regarding 1 way ANOVA, 2 ANOVA, what are conditions, there will be different discussed in a different session. But there are certain conditions to be fulfilled. Certain conditions to be fulfilled if you are going to use a t-test. Now let's go for t-test. So t-test, you have three cases. One is one sample t-test, another is independent sample t-test, another is pair sample t-test. One sample t-test, independent sample t-test, and a pair sample t-test. Now, if you want to apply this t-testing, certain assumptions to be followed. Vicky, is it okay or sound okay, Vicky? Vicky?
Sound okay, sir?
Okay. So sometimes from the back there is some sound. I thought that. So assumptions is normal distribution. The data that you collected should manifest normal distribution, homogeneity of variance. Data. See, this assumption is after fulfilling this assumption only you have to go for t-testing. This cannot be mentioned here. Data must be either interval or ratio scale. Data should be collected either on interval or ratio scale, and there should not be any outlier. And remember one thing. If you want to go for testing of the hypothesis, then the data should be collected by using the probability sampling. If the data are not collected on the basis of probability sampling, then forget about going for hypothesis testing. Hypothesis testing techniques are available to those data collected by using probability sampling only. So non-probability sampling, for non-probability sampling on you cannot do the generalization. So there is no need for testing the hypothesis. Clear? So now let's go for this one. The first assumption is normal assumption. Why? Why normal distribution assumption is needed? Why? Before testing, before application of t-test, you have to check whether the data collected from the field by using the probability sampling method is having normal distribution or not. So, but why? Why? The question is why. So let's go to that. Now, why normal distribution? For that, I have to go back again. In social sciences, two types of variable you come across. Two types of variable. One is continuous variable and another is discontinuous variable. So what is continuous variable? It can be divided into whole number as well as fraction. Continuous variable is also called criterion variable. It can be divided into whole number as well as fraction. Examples are your achievement, score on achievement, score on anxiety, adaptability, and then cost, weight, job satisfaction. So these are all continuous variable. Here I need not to explain why, but these are all continuous variable because this can be whole number as well as this can be fraction. And this continuous variable is also called discrete variable. It can be expressed only in whole number, like gender, male, female. I can't say that male half, female half. So male, female. Residential, rural, urban. I can't say that half rural, then here caste. I can't say that it is half OBC, half SC. I can't say that. So these are all discrete variable. Number of pages should be either 11 or 12. You can have 11 and a half. So languages. So you have Assami, Bengali. So languages are all discrete variables. Now, in the case of experimental research, you'll be talking about dependent variable. Here again, continuous variable. You'll be talking about independent variable or treatment variable. These are all discontinuous variable. So in research, you'll be talking about two variables. One is continuous and one is discontinuous. And often your dependent variables are often the variable of your interest that you want to analyze are continuous variable. And this normal distribution happens to be the most useful theoretical distribution for continuous variable. The continuous variable, so anxiety is continuous variable, and you are going to measure the anxiety. And this continuous variable should demonstrate normal distribution. So here the theory says that the normal distribution or normal probability distribution happen to be the most useful distribution, theoretical distribution for continuous variable. That's why the variable that you are going to analyze is continuous variable, and because of this, the data that you have collected should manifest normal distribution. The properties of normal distribution is that the normal curve is a bell shape and symmetrical in the appearance. It is symmetrical, half symmetrical. If the curve is folded along its vertical axis, the two halves will coincide. And again, the height of the curve for a positive division 3 unit is the same as the height of the curve minus division of 3 units. So let's see here. The normal curve, height here will be same. hide here, hide here. So equal deviation from the mean, equal division from the mean. If you do like this, then height will be same. And if you divide here, then this half and this half are symmetry. Symmetry. So then the area under normal curve distribute as follows. This is very much important because this will decide your alpha level and this will decide your Z value. Now, here you see if 68.27%, if this area covers 68.27% of items, then it is at the value of at the positive side of sigma and negative side of 1 sigma. And these 2 sigma. So 95.4%, it is when Z value is 2. You remember the Z testing when the Z value is 95.45, then Z value is 2. And at 90, then at the 95% Z value is 1.96. So you have to, the area covered and your Z value and alpha value. Alpha for testing the signal are correlated. From this, you can indirectly infer what is alpha value, beta value. So this is normal distribution of when this mean becomes 0. When this mean becomes 0, it becomes Z distribution with the limiting in 0 and the standard deviation 1. But in the case of normal distribution here, mean is mu and the standard deviation is sigma. But when you convert this into Z scale, mean is 0 and the standard deviation is 1. So this often when you do during the time when you used to make calculation for Z testing, calculated value and the table value, we refer to that. There your area is here. From this, the amount that you take about alpha for deciding acceptance zones, rejection zone, all these are related with the Z scale. And this is standardized Z distribution. And this is normal distribution. Okay. Now, if it is symmetry, then it is normal distribution. But if it is not symmetry, then it can be skewness. It can be skewness. Skewness means your data is like this. Majority of the data are on the right side with the low value. With the higher value, majority of the data are being skewed, are scattered on the right side. Here, majority of this data are scattered on the left side, and it is away from the normal. And it becomes asymmetry. Asymmetry is caused by the skewness. Now, what is skewness? When a series is not symmetrical, it is called skewed. Skewness refers to the asymmetry or lack of symmetry. Lack of symmetry in the shape of the frequency distribution. Lack of symmetry. So if there is lack of symmetry, then your distribution is not normal. Now then, whether your data is having normal distribution or not, you have to find it out by using the skewness value. By referring to the skewness value, you will conclude that, oh, my distribution is normal or abnormal. Then it can be positively skewed. In the case of positively skewed distribution, the frequencies in the distribution are spread out over a large range, over a large range of value on the high value end of the curve. There is right-hand side. On the right-hand side, there is a great range of spread out over a great range of value on the right side. But in the negative side, spread out over a great range of value on the lower value side. So skewness means dissymmetry, and we are looking for symmetry. Skewness means asymmetry or lack of symmetry. By looking at the value of the skewness, you can say that your distribution is normal or not normal. If the data is spread on the right-hand side more, then it's positively skewed. If data is spread more on the left-hand side, then it's negatively skewed. Or it can be like this. Here it is positively skewed. Here mean is more than the median more. Mean is, in the case of positively skewed, mean is more than the median more. But in the case of normal distribution, mean, median, more are equal. Then in the case of negatively skewed here, mean is less than median and more is has the largest value. So from this you will come.
Sorry to interrupt you, sir.
Yes.
Participants are requesting you to go a little bit slow. They feel that you are going fast.
Okay. Thank you. So what we are looking for is normal distribution, symmetry, left side, right side symmetry. Now, as I have already mentioned that if it is not a normal curve, then you can't apply t-testing. Then your data should be tested whether it is normal or not. But by looking at the skewness means not symmetry or asymmetry. So if it is asymmetry on the left side, right side, then you can't apply t-testing. You can't apply, but there is a limit of tolerance. To what extent of asymmetry you can tolerate. I will show you the value later on. So this symmetry can be on the left side, right side, and if it is like this, then it's called skewness. But in the case of kurtosis refer to the more thickness or flat top than the normal distribution. It is like this. It is normal distribution, and if it is more peak than the normal distribution, then it is not a normal distribution. If it is less flat than the normal distribution, then again it is not a normal distribution. If it is like this flat, you can't apply t-testing. If it is like this top peak, like positive kurtosis or leptokurtic, you can't apply t-testing. T-testing can be applied only when you have this normal, like this normal. Then, okay, you will not find exactly normal. Then to what extent it is acceptable? So there is some value. To what extent of kurtosis is acceptable? So I will give you the value. So again, let me remind you one thing. Until it is normal or within the range, acceptable range, then you can't apply t-testing. T-testing can be applied only to normal distribution. So your data has to be checked, verified whether it is normal distribution or not with the help of kurtosis and skewness. And again, why normality is important? I have already said at the beginning, since your variable of interest is continuous variable. Now, for example, when you identify the topic of your research, you have to identify the variable or the problem. Your variable will refer to the variable of your interest, maybe anxiety. You are measuring the anxiety, or you're measuring the adaptability, you're measuring the work-life balance, you are measuring the job satisfaction. All these are called variable, and it should be there in the topic itself. Your topic will indicate what is the variable. Your topic will indicate what should be the research methodology, and your topic will indicate what should be the population of study. So identification topic is very much important. In the topic itself, your variable is there, your variable of interest. Now, why is normal distribution data important? The normal distribution is the most important probability distribution in statistics because it fits many natural phenomena. For example, height, blood pressure, measurement, the IQ score, all falls into normal distribution. So one reason that we are looking for normal distribution is that many psychological and educational variables are distributed approximately normally. So normal distribution is a must. Now, with the help of histogram also you can check. With the help of histogram also you can check whether the data is normally distributed or not. Particularly this is true for large sample size. In the large sample size, you can check with the help of figure. And in the last session, even the madam was telling that, in fact, I was there, that, and then again, some of the participants was telling that the graphical presentation catches the eye. So graphic presentation plays a very important role. But here, in the case of sample size very large, histogram are graphs that display the distribution of your continuous data. They are fantastic exploratory tools because they reveal the properties about your sample data. Since your data of interest is continuous variable, and then again, whether it reflects normal distribution or not, it can be easily seen with the help of histogram like this. So this is normal distribution histogram. If it is distributed like this, then this is called normal distribution. And if it is like this is called rightly skewed, positively skewed, and it is called negatively skewed. If the large number of data are extended towards the left side, then it's called negatively skewed. If large number of data are scattered towards the right side, then it's called positively skewed. So with the help of, if the sample size is very large, then you can check whether it's normal or not with the help of histogram. Then again, you'll find box plot. Then what is box plot? With the help of box plot, again, you can check when the sample size is more than 300. With the help of box plot, again, just now in the last session, you have done this box plot. With the help of box plot, again, you can identify whether data is normal or not. Box plot, in descriptive statistics, a box plot is a method for graphically depicting the group of numerical data through the use of quartiles. A box plot is a graph that gives you a good indication of how the values in the data are spread out. Now here, box plot. If this is in the middle, then it is normal distribution. And if the box is on the left side, then it's rightly skewed. And if the box is on the left side, this one box will switch towards this side, then it's left skewed. So in the left skewed, more number of data are there on the left side, and in the right skewed, more number of data are there on the right side. In a normal distribution, it is equal. So whether the data that you have collected is normal or not can also be seen by using the box plot. If it is in the middle, then normal. If it is in the large number of data are on the right side, then right skewed. If large number of data here or here, then it is left skewed. And this is the median. This will indicate. This is the median. This will help you. And these are the quartile. So this thing I will simply, you have to look at the figure. You need not to calculate the Q1, Q2, Q3. But by looking at the figure, you can say that your data is normal or not. Now again, another QQ plot. With the help of, if the sample size is less than 300, with the help of QQ plot, again you can decide, you can think, you can infer whether the data collected was normal or not. If the data is normally distributed, the points in the QQ plot, normal plot, lie on a straight line, diagonal line. A normal probability plot, or more specifically quartile plot, shows that distribution of the data against the expected normal distribution. Now, this QQ plot here, if all the data lies on a line, then it's already normal. See, this is symmetric normal QQ plot. And then here, for the positively skewed, your QQ plot will be something like this. You will not lie on the line. And for the negatively skewed, it will be like this. So from this, we can infer that mine QQ plot, mine data is normal. If it is like this, then it will be normal. If it is always like this, then it is normal. To some extent, here and here is there, but it is acceptable. But if it is like this, then it is negative, it is like positive. So here your data is not normal. So you can't apply the t-testing. So this is all about the basic background. And regarding the second assumption, there is first one is normal distribution. Second one was homogeneity of the variance. Means standard deviation square of the first group should be equal to standard deviation of the second group square. Variance means standard deviation square. So first group's variance equal to second group's variance. Why? Why? Because one of the most important objective of statistics is to give one single figure. Here, all those variants will be pulled together to give one variance, which is called within the variant, within the group. So I will show you that. Then the last assumption is outlier. So variance. So second assumption was homogeneity of variance. Means the variance within each group should be equal for all the groups. So standard deviation one's variance for the first group, second group should always. Why this required? This assumption is needed in order to combine or pull the variance within the group into a single group within group. So this assumption is needed. So this assumption is okay. Then again, last one of outlier. There should not be any outlier. Then what do you mean by outlier? An outlier is an observation that appears to deviate markedly from the other observations. A particular group of data which is totally, which is deviated much from the remaining group of data. An outlier is an observation that appears to deviate markedly from the other deviation in a sample. Identification of potential outlier is important for the following reason. An outlier may indicate bad data. For example, the data may have been coded incorrectly, or an experiment may not have been run correctly. An outlier is an observation that lies on an abnormal distance, from the other value in a random sample from a population. So an outlier is an observation that lies on an abnormal distance. So an outlier arises due to the change in the system's behavior, fraudulent behavior, or human error. So this outlier should not be there. This bad data should not be there in your data. Before analyzing the t-testing, you have to check whether this type of bad data are there or not. But see, if you when you draw the normal curve, you find the outlier. So this is the normal curve, and far away from the normal curve, you find some data. So these are outlier. And again here also, some data are here. out of the normal, some data are here. This green is a normal, some data are outside, these are outlier. Now, the question is, pay attention. Now, for t-testing, these are assumptions. Now, if these assumptions are not being fulfilled, then what to do? You have spent 3 years in collecting the data. Now, finally, your guide asks you to submit the thesis. Then you found that at the beginning I thought that I will be applying t-test, and now that all assumptions has gone wrong because my data could not fulfill all the assumptions. Then what to do? So what do I will tell you later on what to do? Whether I have to start collecting the data newly from the field, or what can be done with the data that is available with you, or whether you should drop the idea of completing PhD. You have collected data continuously for the last 2-3 years, and now you find that all the assumptions are wrong because your data do not fulfill all the assumptions. Then what to do? Whether to manipulate the data, or whether to drop the idea of completing the PhD, or is there anything else? Is there any alternative approach? So I'll be telling you the alternative approach later on after completion of these 3 testing. Now, as I've said that at the beginning, you collect the data, then summarize the data. Before that, categorization of the data, then tabulation has been done. Then you have to test. You have to test the data whether the data fulfills all these assumptions or not. Now, so you have this data. You have entered data in Spss spreadsheet. You have entered data. Suppose your coding is, your male is 1, female is 2, and type of school, 1 is private school and 2 is government school, and location school, 1 is suppose urban, 2 is rural, and for each teacher, say for the first teacher, his level of stress is 56. For the second teacher, then you have collected through questionnaire 58. So you have entered the data. After entering the data, you have to see whether this data fulfill all the assumptions for testing T or not. After you fulfill it, then you are ready for going for T testing. So after entering this data, you have to check whether your data collected from the field fulfill the assumptions or not. Then what are the approaches of checking the normality? What are the approaches available? First one is called descriptive statistics. You will check with the value of skewness and kurtosis, and you will check with the or you can check with the standardized Z skewness, standardized Z kurtosis, which is the ratio of skewness minus divided by standard error of skewness. And kurtosis, Z kurtosis, you take the kurtosis from the analysis, and then you divide it by standard error kurtosis. So either you can check with the help of descriptive statistics, or either you can check whether your data is normality or not with the help of significant testing. If sample size is more than 50, then Kolmogorov-Smirnov test of normality. And if the sample size is less than 50, then Shapiro will test. And if the sample size is greater than 300, the histogram is there to check whether your data whether the data collected from the field is normally distributed or not. And with the help of box plot also, just shown box plot and QQ plot. If the sample size is very large, then with the help of graphical method, you can check whether data collected is having normality or not. So summarization, now let me summarize it. When the size of the sample is less than 50, for testing the normality, Shapiro will test, and the Z-Qness and Z-kurtosis, you use it. If the p-value is greater than 0.05, in the Shapiro will test, then your data is normally distributed. And if the value of Z-Qness, Z-kurtosis lies in the range of plus or minus 1.96, then your data is normally distributed. But if the sample size is greater than 50 but less than 300, then you use Kolmogorov-Smirnov test for normality. If P is greater than 0.05, then your data is normally distributed. If not, then your data is not normally distributed. And if the sample size is greater than 300, then your preferred approach is skewness, kurtosis. Now, if your data will be normal if the skewness lies and equator lies between plus minus 2. Or in the histogram, for a histogram I have shown to you, for box plot I have shown to you, in the box plot the figure should be, the median should be in the middle. But remember one thing, some authors said it is plus minus 2, some authors said something else, but which one you are following? And which one you are following? Oh, so you have to indicate in your research work like this. The value for symmetry and kurtosis between minus 2 and plus 2 are considered acceptable in order to prove normality, normal univariate distribution by George and Mallory 2010. It said, and Bryan 2010 argued that the data is considered to be normal if the skewness is between disease and kurtosis minus 7 to plus 7. So some statisticians have different view, but which one you are following? Which one you are following? You have to quote. But here I am following this one. George and Mallory 2010. I'm following this one. So you look at this and decide which approach to be followed depending upon the sample size. Okay. Now let's go for one sample test. The first test, one sample t-test. Here one sample t-test. Now I have to check whether it is normally distributed or not. And then I have to check whether there is any outlier or not. Earlier, we used to calculate by using this formula. Mean of the sample minus mean of the population divided by standard error. So we used to calculate that this one. Now this calculation portion will not be done by you. Now Spss will do it. But before that, there is test assumption. Now for one sample test situation, I'm giving one situation. A manufacturer of a bulb claimed that the mean life of his bulb is 25 months. But after we make a survey and we found that life of the first bulb is 24, life of the second bulb is 26 months, life of the third bulb is 30 months, and so on. Now, can you regard the producer's claim to be valid at 5% level of significance? So, in such a situation, suppose you have conducted a sample survey in Silchar, and you found that the mean income is you found that 5,000 per month. But statistical data supplied by the Assam says that mean income of Assam, entire Assam is say 20,000 to 2,000, 4,000 per month. So your sample says 5,000. The claim by the statistic says 4,000. Is there any significant difference or not? In that case, you can apply one sample test. Clear? So here population mean is already known from the statistical data, or here it is given mean life, there is population estimating mean is given. But you collected a sample from the Silchar, and Silchar is part of the Assam. So whether the claim made by for the entire Assam is valid or not, you can check it. So likewise, this you go through the question carefully. Manufacturer of a certain make of electric bulb claimed that his bulb have a mean life of 25 months. A random sample of 6 such bulbs gave the following values. Life 8 months, this is this. Can you regard the producer's claim to be valid in 5% or not? Now, first let us say this sample data is 24, 26, 30, 20, 20, 80. You just note it down. The sample data is, for the first bulb is 24 months, 26 months, 30 months, 20 months, then 20 to 18. Let us check whether these indicate normal distribution. Before applying t-test, before verifying the validity, let us check whether this sample data exhibits normal distribution or not. So note it down, 24, 26, 30. So let us enter this data. So life of the bulb, my variable interest is life of the bulb. It is numerical data. So it is scale. So it is scale. The data is collected on metric scale. So the data view. So 24, 26, 30, 20, 20, I mean 30. So after entering, so your variable of interest is life of the bulb. So then enter the data entry has been done in the first session, how to enter data. Now for checking the normality, please note it down. Go to analysis. First go to analysis for checking the normality, go to analysis, then go to descriptive statistics, then go to explore. Please note it down. For checking the normality, go to analysis, go to descriptive statistics, then go to explore. Now, after opening the explore, you'll find the here box. Now, dependent variable, you are interested in finding the life of the bulb, and there is the continuous variable, so you go there. Okay. Now you go to the statistics. Is there any outlier? Is there any outlier you want to see? Then continue. Go to options. Options. Okay, continue. Regarding that plot, you want to check the normality with the help of Shapiro. You just do here. If you want to put here histogram, you put histogram. But for a small sample size of this, you will not be able to indicate idea from the histogram. As I have mentioned that histogram can be used only when you have a large sample size. Now ready? Now you're ready. Now you open here in statistics. Outlier, you click it. In 95 means you will be testing at alpha 5%. Then plot, you go to the plot. You tick here normality plot. Continue. Then here in the option, okay, it's okay. Now you click here, okay. Have you got Vicky? Have you got this diagram? Vicky, Divjyoti?
Diagram is not there, sir. Only the table.
Diagram is not there.
No, the descriptive is I'll show diagram. Descriptive is here.
Is there.
Yes, sir. Yes, sir. Yes, sir.
So please, all the participants, please note down. Excuseness here is 0.625. Please note down. And the standard error of excuseness is 0.845. See, all the output given by the calculation we don't need. Whatever is relevant to you, just take it. So whatever is relevant to your area of study, what is relevant, you just take it. Those which are not relevant, just forget it. You just pick out which is relevant to your study. So to my relevant of study at this juncture is I want to test the normality, and normality can be tested with the help of skewness. So please note down this skewness value 0.625. Please note down kurtosis minus 0.750. Then standard error, this is standard error. Standard error of skewness is 0.845. Please note down. Standard error of kurtosis 1.741. Please note down. Then, since it is sample size is less than 50, you note down your Shapiro. Shapiro statistics is please note down 0.933. Degree of freedom 6. Significant point level is 0.6. 0.6. All the participants, I'm requesting all of you, please note down this value. Excuseness, kurtosis, then since sample size is less than 50, Shapiro with 0.933, degree of freedom 6, and significant 0.6. After noting down all this, it is customary that you have to make a table. And then in that table, the heading should be descriptive statistics, then you have to mention all these things. Now, if the sample size had been more than 300, you could have used histogram. So since sample size is very small, so it is very difficult to depict from here. Then here QQ plot, and here you have box plot. Box plot it would have been exactly normal if this median is it should have been here. So if the sample size is less than 300, then it is more appropriate. Otherwise, right? For this, let us go for descriptive statistics. After noting down all this, now let us go to the earlier slide. Now you make a table. Whatever we have noted down, and this is descriptive table, descriptive statistics table. Here I will be finding the Z skewness, kurtosis of the sample distribution. Whatever we have not done from there. What was the skewness? 0.625. What was the standard error of skewness? 0.845. What was kurtosis? Minus 0.750. What was this was taken from the output. Now Then what is Z skewness? Z skewness is skewness divided by standard error. So 0.396. What is Z kurtosis? Kurtosis divided by standard error. It is 0.430. Now you look at this. These two values of Z lies between minus 0.096 and 1.96. So 0.396 is less than 1.96. And your minus 0.4307 is also greater than minus 1.906. So it lies here. It lies here. So minus 0.4 is nearer to 0. 1.96 is farther away from the 0. So minus 0.30 is greater than minus 1.96. So Z value is greater than minus 1.96, or you can say this two value of Z is Z lies between 1.96 to 1 plus 1.96. See, for the negative side, minus 0.4 is greater than minus 1 because minus 0.4 is nearer to 0. Minus 1 is farther away from the 0. So minus 0.4 is greater than minus 1. So, or you simply say below of Z is between minus 1.96 and plus 1.9. So this indicates that your data is normal. But again, there is support by another. Safiro will test 0.33. They have noted p value have noted. So this p value is greater than 0.05. Automatically, if you refer to the table here, if the p is greater than 0.05. For sample size less than 50, if the p is greater than, it is normal. It is normal. And if the Z skewness is between plus minus, then it is normal. So after this, you interpretation. So you have the table, then extracting the meaning from the figure is called interpretation. You have to extract the meaning from the figure. From the table number one. It is observed that the value of Z skewness and Z kurtosis are this respectively. Thus, each one of these measures lies between plus minus 1.96. Hence, the distribution is normal. Then again, for table number 2, table number also support the above result for n less than this one. Safiro will test this, and this p value is greater than 0.05. So the distribution is normal. Now the data collected from the sample data is found to be normal. Now after this, now you are ready for testing using the t-test. Now you are ready for applying the Spss t-testing. Now for that, before every hypothesis there is objective. So you note down the objective here. Objective is, so this was a statement. So manufacturer of a certain make of electric bulb claimed that his bulb have a mean life of 25. And see sample, can you regard the producer's claim to be valid at 5% level of significance? What can be the objective now? What can be the objective? Objective to compare the mean of the population and the mean of the sample, or to verify whether the claims of a manufacturer of a certain make of the electric bulb there is bulb have a mean life of 25 months is valid. This is the objective. You wanted to see, I'm collecting the sample to see that the claim made by the producer is valid or not. So your hypothesis will be there is no significant difference in the mean of the population and the sample, or alternative hypothesis, there is significant difference in the mean of the population and the sample. See, some those who are beginner may be thinking that what type of hypothesis is this? There are 5 ways of setting the hypothesis. There are 5 ways. I'm showing you. Research after the object, your hypotheses are being framed on the basis of objective. So the first type of hypothesis is there is no significant relationship between the gender and anxiety. For example, or here it can be there is no significant relationship between the mean life of bulb of mean life of the sample and the mean life claimed by the manufacturer. There is no significant difference. You can say like that. So normally there are 5 types of hypotheses. First one is research hypothesis. You can step like this. Statistical hypothesis, there is no significant difference. You can say like this. Directional hypothesis, there is significant difference. You can say like this. Or operational hypothesis, there is no significant difference in the like this. So there are 5 ways of, there are 4 ways of setting the hypothesis. So you choose any one. This is statistical. After you make the statistical here, null hypothesis should be there. But nowadays, the null hypothesis has been started using as a directional hypothesis. So there are different types of hypotheses. Particularly for statistical analysis, we use the statistical hypothesis or directional hypothesis. But if the questionnaire in that your items are being they are being already standardized by somebody else, then you have to use operational hypothesis. This thing I will not discuss here. Only I'm telling you that hypothesis can be stated like this. Now, our hypothesis here is there is no significant difference in the mean of the population and the sample mean, or like this. The mean of the population is not different from 25. 25 what it was claimed. The mean of the population of the bulb, the mean life of the population of the bulb is not different from 25 months, means equal to 25. So this degree of freedom I have just calculated it, but it has been already given by the it will be given by the analysis part. Now let's go for t-testing now. Let's go for t-testing. T1 sample test. After preparing the background, now let's go for one sample t-test. Vicky, still no disturbance, okay?
No, sir. No, sir.
So after checking the normality, now after seeing all those things, now you are ready for t-testing. Your original data was this one. Your original data was this one, 24, life of the bulb, sample data, 24, 26, 30, 20, 20, 20. But one data is that there the manufacturer, or not the manufacturer, claimed that 25. The mean life of my bulb, all my bulbs will be 25. That was the population mean. Now you go here and please note down for one sample t-testing. Please note down. Analyze. Earlier was for testing the normality. Now for one sample t-testing, go to analyze, then go to compare mean. Go to compare mean. Do note down. Analyze, compare mean. Go to one sample t-test. One sample t-test is here. So first case in the t-testing is one sample t-test. Now you click here. So your test variable is life. So your test variable, your variable interest is life of the bulb. So you click here, go there. Now, the claim made by the manufacturer is that the mean life of the mean lifespan of the bulb of my bulb is 25 months. So you enter here 25. 25. Go to option. So 95 means you will test the hypothesis at 5%. Then the rest is okay. Okay. Now here you note it down here. N is 6. Your mean is here. Mean of your sample. The mean of the standard deviation is here. But your population mean is 25. Already test value is 25. So your mean of the sample is 23, and the mean of the population here is 25. So difference is how much? Difference is -2. How much? 25 minus 23. So difference is 2. Whether this difference of 2 is by chance or in reality there is a difference. Why we are testing the significance? This difference of 2, whether it is by chance because we have used a sample, or in reality there is a difference. If there is no significant difference, then you will draw the conclusion that the difference happens because of chance only. In reality, there is no difference. But if this difference is significant, then you can say that even though by chance there may be some difference, but truly there is also a difference between the mean of the population and the mean of the sample. So you note down here p-value. So minus is nothing, but see, if 25 comes earlier, then it will become positive. Here it is 23 minus 25, so minus here. So don't get confused. Always will take the absolute value. Whether you take 25 first or you take 23 first, because of the already having minus sign. Minus sign here is because 23 minus 25. So here minus 2 is also here. So what you have to note down here? N mean standard deviation, t value, degree of freedom and a significant 0.328. Significant is 0.328. Please note it down. Significant, your significant p-value here is 0.328. Please note it down. Now, after this noting down, you have to make a table, summary table. So let's go out. One thing, since one thing, after taking the data, with the help of data, you have to draw the conclusion. So there should be heading: comparison of mean of the population and the mean of the sample. Say in writing, the objective was to compare the mean of the population and the mean of the sample. Data was analyzed with the help of t-test, and the results are given in the table number 1. Yeah. So when you, even for publication, even for thesis, also you require heading first. Heading you require. Then you have to say that the objective was to this, and after analyzing, the data is presented. So here it is presenting the data. So for the sample mean this one, standard deviation. For mean population here, your t value is here. You take the absolute value, because it is minus plus is depend upon which one you have taken first. So you take absolute value. Now here p value is 0.325. It is greater than 0.05 or not. Your p value is greater than 0.05. So p value is greater than 0.05. There is no significant difference. That means there is no significant difference. There is 25 and 23. There is no significant difference. And the difference of 2 was by chance. Since 0.32 is greater than 0.05, the difference of 2 was by chance. By chance, in reality, there is no difference. So your interpretation from the table number 1, it can be seen that the t value is 1.085, which is not significant at 0.05 level of significance with degree freedom 5. It means that the mean of the population and the mean of the sample do not differ significantly. Thus, the null hypothesis, there is no significant difference in the mean of population and sample mean, is accepted. So some people prefer to say not rejected, but even you can see not rejected means what? Accepted. So that's the null hypothesis. What was your null hypothesis? The mean null hypothesis that the mean of the population is not different. The mean life of the bulb is not different from 25 months. Not different from 25 months. Is accepted. Means mean life of the bulb is equal to 25. So that's a null hypothesis that there is no significant difference in the mean of the population and the sample is accepted. Therefore, the producers claim that his bulb have a mean life of 25 months is valid at 5%. So you have to interpretation is the process of selecting the interpretation is the process of selecting the meaning, extracting the meaning from the figure. So from the figure we extract the meaning. Now second case, independent sample t-test. Second case is independent sample t-test. Now here assumption, normal distribution, homogeneity, and there should not be any outlier. Earlier, what we did numerically we calculate the mean of the sample 1, mean of the sample 2, divided by standard error, and the complicated formula for standard error is this one. This is when you have the population standard deviation. So you call 1 by n1 sample size 1, sample size. So we used to calculate like that. Now calculation work has been done by your Spss. Now what we have to do is now go. Now look at this situation. I'm giving you a situation for 2 sample tests. For t-testing, 3 cases. One is 1 sample t-test. Second one is 2 sample t-test. So 2 types of drugs were used on 5 and 7 patients for reducing their weights. Drug A was imported. Drug B is indigenous. The decrease in the weight after using the drug for 6 months was given below in the table. Is there any significant difference in the efficacy of the 2 drugs? So is there any difference in the efficacy of the 2 drugs? Or you can say, is there any difference in the stress level between male and female teachers? Is there any difference in adaptability to the changing environment between the boys and the girls? So you can test when there is two group and you wanted to know whether there is significant difference or not. So mean income of girls and mean income of teachers and female employee and the mean income of male employee, is there any significant difference or not? Stress level, then adaptability, job satisfaction between the male and female, is there any significant difference or not? You can do with the help of two sample t-tests, independent samples t-tests. Independent sample t-test or independent two sample t-test, you can do it. Now, our role is now here, whether this data is normally distributed. Before applying t-test, whether this data of drug one, this data, drug B, this data, whether separately, whether these two distributions are normally distributed or not. Clear? We have to see this one. So now you have to enter this data and you have to see whether this group is normally distributed or not, whether this group is also normally distributed or not. And regarding the homogeneity of the variance, there will be automatically come out when we go for t-testing, automatically come out. So no need to check that. Here you can check the outlier as well as the normality. Now let's go for checking the normality. As I have said that before applying, go for testing the assumption, whether the data are normally distributed or not. Now let's go for, let us enter this data. So if you look at this variable view, you have types of drugs. Your types of drug here level. Here I have given drug A as 1, drug B as 2 in the data entry. But your variable of interest is efficacy. Efficacy. For drug A has given to 5 people. Drug A has been tested to 5 people. 5 people, drug A is 1. So 1, 2, 3, 4, 5. So these are the reduced in weight or efficacy. Reduced in weight or efficacy, this one. And drug B, 1, 2, 3, 4. These are the data that I've entered. So drug A given the code name 1, coded as 1, and drug B coded as 2, and these are their values. Their values that I've just shown. I've just shown that first person had reduced 10, 12, 13 up to 5. For drug A up to 5. So I've shown to you that. Now for checking the normality. Now please, for checking the normality, go to analyze. Go to analyze. Go to analyze. No, note down, for checking normality, go to analysis, go to descriptive mean and explore. Analyze, descriptive statistics, explore. Now, your variable of interest is what? Your dependent variable efficacy. Efficacy. Click here. But you have two groups. You have two groups. You have drug 1, drug A, drug B, right? So separate group, you have to take. Now statistics, you will require. I want to know outlier also. Outlier. Then plot. I want to test the normality also. Histogram also take it. Then now you're ready. Okay. Now, my dear friend, note it down. For drug A, please note down. For drug A, skewness and kurtosis, standard error of this one. Skewness and standard error of kurtosis. Please note down. So that let's compare it with what I have given in the table. So for drug A, skewness is 0.00. Kurtosis is minus 1.200, and standard error of skewness is 0.916. Standard error of kurtosis is 1.02353. This is for drug A. Now go to drug B. For drug B, skewness is 0.563, and your standard error is 0.796, and kurtosis minus 1.78, 1.587. Now for the since sample size is less than 50 Safiro. So for For drug A, Safiro statistics is 0.987, degree of freedom 5, significant p-value 0.967. And for drug B, statistics is 0.902, degree of freedom 7, significant level 0.34, p 0.34. This one is 0.9. Please note down. As the sample size is very low, let's not go for histogram. Let's not go for the PP, QQ plot also. Let's not go for your box plot. So since sample size is very less, we can do it without the graphic method. After noting down for the two sample t-tests of normality testing, now let us go for. After noting down, now, so whatever whatever you got from the output, those relevant statistics, you just take it out. Others, forget it. What is relevant to you, take it out. So what was relevant to me was for drug A. For drug A, skewness, standard error of skewness was relevant to me. For drug B, skewness, standard error of skewness was relevant to me. Now, skewness divided by the standard error, I got Z skewness. Kurtosis divided by standard error of kurtosis, I got Z kurtosis. Remark, these two values lies between minus 1.96 to plus 1.96. For drug B also the same thing. For drug B also the same thing. You calculate Z skewness, Z kurtosis. This Z value lies between minus 1.96 and 1 plus 96. So positive. So this indicates that your two group data for drug A and drug B are normally distributed. But let us see what the Safiro says. Safiro also says that the p-value was 0.96 for drug A is greater than 0.96 greater than 0.05 normal. For drug B also 0.34 is greater than 0.5, so normal. So interpretation is that from the table number 1, see, after every data that you have collected from the output, you have to extract the meaning from that. So interpretation for drug A, it is observed that the value of Z skewness, Z kurtosis are this. Thus, each one of these measures lie within plus minus 1.96, and hence the distribution is normal. For drug B also, same thing, hence the distribution is normal. And then for Safiro, for drug A, since the Safiro is this, and since the p-value is greater than 0.05, it is normal. For drug B also, it is normal. So we are ready for testing the using the Spss for two sample t-tests, for independent sample t-test or two samples t-test. Now we are ready. So before that, as I told you that every research has objectives, and your hypothesis is to be derived from the objectives, and then you will go for testing the hypothesis. So for testing the hypothesis that there is no significant difference in the efficacy. So what would have been your objective of research? The objective of my research would have been to compare the efficiency between the drug A and B and the drug B, to compare the efficacy between the drug A and B, or to compare the means of the decrease in weight between the two samples using drug A and drug B. So language you can change it. So to compare the means of decrease in weight between the two samples which use drug A and drug B. Or null hypothesis can be there is no significant difference in the mean scores of the reduce in weight by using drug A and drug B. Or in the case of alternate, there is significant difference. So null hypothesis is no significant. Drug A and drug B are, null hypothesis says that efficacy of drug A and drug B are equal, same. But alternative hypothesis says that efficacy between drug A and B are different. Okay. So let us now, since the normality has been already fulfilled, now let us go for testing. Or you can say like this also, there is no significant difference in the efficacy of the two drugs. There is no significant difference. There is significant difference. You can say like this. You can say in a different way, whichever you like. Alpha is 5%. Now let us go for testing using Spss. Vicky, is it still okay? Vicky?
It's okay, sir. You make
Yes, sir. Yes,
slideshow,
sir.
then
Yes.
the hyperlink will work.
Okay. Means sound is okay now.
Yes, sir. Absolutely perfect, sir.
Last time, because of the signal, it was too much distorted.
No, sir. It's not disturbing any time, sir.
So when the distortion start, nervousness start, because whether I will be able to complete within the time or not.
No, not at all, sir.
So this was my original data. Then after entering that drug A is 1 denoted by drug B denoted by 2, these are efficacy. Now you go through the analyze. First you note down analyze, go to compare mean, go to independent sample t-test. So you are having two sample. If it is more than 2, then you have to go for ANOVA. Now here test variable, your variable of interest is efficacy. You go there. But you are having 2 sample, so grouping, so you have 2 groups. So you define here one was you have to use 1 for the first one. You have used 1 here for drug A. You have used 2 for the drug B. Now options available here. 95% means you are testing the hypothesis at 5%. Continue. Bootstrap, nothing needed. Now you are ready now. We are ready to test. We are use t-testing. Now we are ready to use, ready to know the output of t-testing for 2 sample. One sample is those patients on whom drug A was given. And then another sample is to those patients on them you have used drug B. Now, okay. So now you note it down. Mean of drug A is 12. Please note down N is 5, drug A, and then for drug B N is 7, and then for this one standard deviation you note down 1.5 in this one, 2 point. You note down this one. Please kindly, my dear friend, please note down for drug A N is 5, mean is 12, standard deviation is this. Then for drug B, N is 7, mean is this, standard deviation is this. Now you come here. So here, Levin stage. One of the assumptions was that equality of variance. So here 0.09 is greater than 0.09 is greater than 0.05. So equality of variance is there. Equality of variance is there. 0.09 is greater than 0.05. So it justifies equality of variance. So that second assumption, equality of variance, you have to look at the Levin stage here. Clear? Levin stage. And then t value is 0.735, degree of freedom 10, and your p value is 0.475, p value is 0.745, and it is greater than 0.05. So you are going to accept or reject null hypothesis. Your p value here is 0.75, greater than 0.05. Are you going to accept or reject the hypothesis? Now you are going to accept the hypothesis. And your hypothesis was there is no significant difference in the efficacy of the drugs. Your drug A was important, drug B was indigenous. So even though your drugs may be, whether your drugs is important or indigenous, it hardly matters. Both the drugs are equally good. So after noting down this so there's so many things in the output. So you take it what is relevant to you. You just take it what is relevant to you. What is not relevant, don't bother to think much. I also don't know what are the other. What is relevant to me, I'm taking. What is relevant to me is N is relevant, mean is relevant, standard deviation is relevant. Even here, Levin's, this one is relevant to me. Mainly T value here and this one. 0.79, 0.711. So I'm taking it. Now let's move out. No saving. As I have said, that for every analysis there should be a heading. So my heading here is comparison of mean comparison of means of decrease in weight between the samples, using drug A and drug B. So this is a heading. So the objective was to compare the means of decrease in the weight between the sample using drug A and the drug B. The data were analyzed with the help of the t-test, and then the results are given below. So this is from the output I have taken. From output, we have taken mean of drug A, this one, standard deviation we have taken, and we have taken t value we have taken, and this, and then p value we have taken. What is the p value? T value. P value, I should have made here separate column, but I have not made here separate column. But we have noted down now. We have noted down the P value was 0.97 and is greater than 0.05. And what is the meaning of this? Null hypothesis is accepted. So it means null hypothesis is accepted. Now interpretation. From the table number 1, it can be seen that the t value is this, which is not significant at 0.05 level of significance with degree of freedom 10. It means that the means of the decrease in weight between the samples using drug A and drug B do not differ significantly. Thus, the null hypothesis is that there is no significant difference in the mean score of the reduced in weight by using drug A and drug B is not rejected, they are accepted. Therefore, there is no significant difference in the mean scores of reducing weight by using drug A and drug B. There is no significant difference in the efficacy of the two drugs. So, like this, we test. First, we go for testing the normality, and then go for the t-testing in the Spss. No need to calculate much. Now you got the result. Now last one. Now I'm having how many minutes left? Nibo?
Sir, almost 45 minutes.
Okay. Now the last one is pair sample t-test. Assumption is same, but here one thing is that we have to test the normality of the difference. This one is mean of the, this one is actual formula is this one is mean of the difference. But here in the we will be checking the normality of the population difference score. D refers to difference in the score. Before the coaching, after score of the student before the coaching of mathematics, score of the students after the coaching of mathematics. So, is there any difference in the score? There is D. D represents the difference, and D bar will be the mean of the difference. So earlier we used to calculate manually like this. Now forget about all these things. Now Spss has taken care of your headache, and Spss will calculate it. Now let's go through the situation. To verify whether a coaching in mathematics or statistics improve the performance of the students or not, a similar test was given to 12 participants both before and after the course. The original marks recorded in alphabetical order of the participants were given. Here, I can add the name of the students, A, B, C, D. But that I'm not adding it. It says that the original mark recorded in alphabetical order of the participants were given below. So A student got 44 before the coaching and 53 after the coaching. Now B student got 40 before and then 38 after the coaching. So in that way, this is arranged. Here you can put roll number of the student or name of the student, and this is the results of the third student. So this thing can be done before the advertisement awareness level of the consumer, after the advertisement awareness of the consumer. So whether the advertisement was effective or not. Particularly I'm from marketing and background. So before the advertisement, awareness of brand A. What is the level of awareness? Then after the advertisement, what is the level of awareness? So whether the advertising was effective or not. Then again, before using a particular herbal face makeup. So some expert will examine your condition of your face. And then after the application of that herbal medicine, so after say 3 months, what is the condition? Whether it is improvement or not improvement, noted by the beautician. Then we can see that whether that particular medicine is effective in making the face beautiful or not. That also can be done. So in such a case, your sample remains the same. So this is called pair sample. Why it is called pair sample t-test? Why it is called pair sample t-test? Pair sample t-test means the individual remains the same. So the sample remains the same. but we have measured twice, before and after. Before and so that's why it is called pair sample test, or it is called dependent sample test also. Second case was independent sample test. This pair sample is, you can call it dependent sample test also. Yeah, because the same sample was used. Now let us enter the data. So this is before, this is after, and this you can get it by transformation. So you see, there is transformation is here. Transformation of variable is there. You can compute, or simply you can go with the hello calculator. You can compute and give here. Or if you don't want to do manually, then here is transformation is here. Compute variable is here. Then here you can make the difference DIFF, and then you can before after is here. Then you can easily calculate it, automatically will come here. So data transformation, I suppose it was done today or before yesterday. You have done it. So you can do it, or simply by calculation 53 minus 44, 9, and then 38 minus 40 minus 2, simple. Now, as I have just mentioned that here. In the execution, I have said that we have to check the normality of this, not this two. Even if you do it, you'll get it. But since these things, we have taken the minus, and you check this one, -1. You can see it. And analysis will also be in the difference. The formula says that you'll be analyzing on D. So D difference meaning you have taken in the formula. I will show you later on. So this is difference. Your internal calculation is on the difference. So you check it now. But you know this normally distributed or not. Analyze. Descriptive, note down, analyze. Descriptive statistics, go to explore. Now, your variable of interest is not the before nor after. Now, because I have given you the formula, there the calculation is being done on the basis of difference. If you know the theory, then you can explain why not before after, why difference here? Because in the theory, the calculation of this pair t-test is difference. So I'm using this difference now. Difference. So you simply go statistics. You can check it outlier. Now you go here. Where is that? Plot. Normality. We are testing normality now. So histograms you see it. So now ready now. So since it is a pair sample t-test, we are checking the normality not separately, but on the difference. Data, after taking the difference, we are checking the normality because in the calculation of t-testing, this one, the formula is mean D. D is the difference. So instead of checking normality separately, we are checking the normality on the difference because this formula, in the formula, the difference is used. Now please note it down. Note it down here. Statistics. See, the difference between the parameter in the statistics is that whatever you calculate from a sample data are called statistics. Whatever you calculate from the population data are called parameter. Constants or whatever the value you derive from the sample are called statistics. That's why here it is called statistics. Here it is mentioned statistics. Clear? So these are the data calculated from the sample. So skewness is minus 0.4. Standard error is 0.637. Kurtosis is 0.7. Standard error kurtosis is 1.232. Clear? Now, since it is sample size is less than 50, Shapiro-Wilk test, statistics copy 0.954. Degree of freedom 12. and significance level 0.699. Since this is greater than 0.05, normal, it has the data exhibits normal distribution. Data manifests normal distribution because here 0.69 is greater than 0.05. But if the sample size have been more than 300, you could have used histogram. This is normal. It is normally distributed. It is normally distributed, and then you can go for QQ plot. So it is nearly to the straight line, and then you can go for box plot. Box plot is somewhere, it is somewhere majority of the data are on the right side, right on the right side below, on the majority of the data are on the right side. So this should be median, should have been in the, to be exact normality, it should be here. But I have already mentioned that the graphing method can be used when your sample size is very large. There is n is greater than 300. Now after noting down, let us go to the slide. So after noting down, you note down here, after noting down, we found that Z skewness is this one, Z kurtosis is this one. How you get Z skewness? Skewness divided by standard error of skewness. How do you get Z kurtosis? Kurtosis divided by standard error of kurtosis. And this Z value lies between minus 1.96 and then plus 1.96. So it is normal. And what about Shapiro? Shapiro p value we have noted down 0.69, and this 0.69 is greater than 0.05. So normal distribution. Then after this, you can go for interpretation that in the table 1, because the Z value lies in this normal distribution. Okay, then Shapiro, since p value is greater than 0.05, so normal distribution. Thus, one can say that the difference of the data before and after the coaching distributed normally. After this, after we found that it is normal, now we are ready for testing whether really the coaching benefits the student or not. Whether coaching benefits the student or not. So objective is to verify whether coaching in statistics improve the performance of the student or not, or to compare the mean score of the performance of the participants before and after the coaching. So your objective can be to verify whether the coaching in statistics improves the performance of the students or not, or to compare the mean scores of the performance of participants before the coaching or after the coaching, or the condition of the face of the ladies before use of the new product, or condition of the face of the ladies after using the product. So whether there is any significant difference or not, we can do that. So null hypothesis, then alternative hypothesis. Now then you can say like the coaching was not useful. Mean always null hypothesis is like not different. Before the coaching and after the coaching, the performance is not different. Means what? The coaching was not useful. Before the coaching and after the coaching, the performance level remains the same. That means what? That means coaching was not useful. Before the coaching and after the coaching, if there is any difference, then coaching may be useful. So null hypothesis, maybe the coaching was not useful. So now after normality testing, we have tested the normality. Now let us go for real t-test, and this is the last one. Remember that the variable of interest or analysis is the dependent variable and always continuous variable, and normal distribution is the appropriate distribution for continuous variable, and for discrete variable you have another type of distribution. Now this was the case before, after, and now let's go for in a pair sample t-test. Analyze, note down, analyze for pair sample t-test, compare mean, go to pair sample t-test. If it is more than 2 samples, then you have to go for another way, but pair sample t-test, go there. Then your pair was before, click here. before to here after. Okay. Option 95 means you're testing at alpha 5%. Continue. Then nothing is here. So let's go now. So here you see pair sample statistics. So mean of the before is 54, mean of the after is 59. You note it down. Mean 54, 59, 12. Standard deviation you cannot learn. Standard deviation is also you can note it down. Standard. So this correlation is not needed here. But if you have happened, if your study was based on correlation R, then you can take this value. And after taking this value, whether correlation R is significant or not, you have to test the T value. But since we are not discussing here correlation, now here you please note down T value. T value is absolute value, take it 3.445, or you can minus, no problem. Regarding coming to -1 is which one have taken fast, whether before have taken fast or after. If I've taken after fast, then this here it will come plus. So since I've taken before fast then after, so it has come here minus. So always you go for absolute. You note down T equal to 3.445 and significant is 0.005. Here it is less than 0.05 or not. Think about it. Here P value is 0.005 and it is less than 0.05. 0.005 is less than 0.05. So note it down. Note it down, this T value, degree of freedom, and this mean, and then standard deviation also. So let's go back. As I have said that when you are doing something in a write-up, there should be some heading, comparison of mean of the performance of the participant before and after the coaching. The objective was to compare the mean of the performance of the participants before and after the coaching. The data were analyzed with the help of pair sample t-tests, and the results are given in the table number 1. So this is my table. So before testing, before the coaching, testing before the coaching is mean is 54. The standard deviation was this, n is this. After the coaching, mean is 59, the standard deviation it is, and the pair sample value is 3.445, and the significant value was 0.005, and this happened to be less than. In the calculation, their significant value was 0.005, and this 0.005 is less than 0.05. Then what is the interpretation? Interpretation is that from the table number 1, it can be seen that the pair sample t-test, it can be seen that the pair samples t value is this, which is significant at 0.05 level of significance with degree of freedom 11. It means that the performance of the participants after and before the coaching differ significantly. Now here t-testing simply says differ, but it doesn't say which one is higher. Here t-testing simply said that the performance after and before it differs significantly, but it doesn't say here which one is better. Now let's go through it. Thus, the null hypothesis that there is no significant difference in the mean score of performance of the participant before and after the coaching is rejected. So it is greater than 0.05, so it is less than 0.05, so differs significantly, that means null hypothesis is rejected and alternative hypothesis accepted. Therefore, there is significant difference in the mean scores of performance of the participants before and after the coaching. But remember, t-testing doesn't say better or not, but you have to observe now. After it says significant difference, now go to the data again. Now let's go back to the data again. See further. The mean score of the performance before coaching is 54, which is significantly lower than, if you look at this, Mean score of the performance before the coaching is 54, which is significantly lower than the 59 by observation from the table. Further, the mean score of the performance before the coaching is 54, which is significantly lower than the mean score after the coaching, where the mean score of the performance is 59. Therefore, it can be said that the coaching was useful in enhancing the performance of the participants. Right? So, I begin with this. And I had asked you one question at the beginning also. So in the t-testing, this one. So for t-testing, your assumptions to be fulfilled. Now I ask you one question. If the assumptions are not being fulfilled, if your data are not being normally distributed, what to do? Those PhD students, they've collected the data for 2 years, 3 years from the field, and finally, when they sit down on the computer, sit down on the table, looking at the Spss and checking the normality, there is no normal distribution. There is no homogeneity. And there are some outliers. What to do? What to do is, please note it down, what to do there. You ask yourself, what can be done? Now I'm suggesting you what can be done. After spending, see, at the beginning, I tell you that data must be either in interval or ratio scale. Some participants who are totally new may be wondering what it is meant by this. There are 4 types of scale. Nominal scale, simply categorization male into female. And the ordinal scale, not only categorization, there is these categories are ranked in orders, maybe first, second, third. So they are being ordered. Not only the categorization, one component order by rank is added. But in the interval scale, not only the order, rank, but then equal distance, but not through 0. This need to be explained. For those who are totally new, I'm telling you, the different ratio scale are higher order scale. So there is a true 0 point and it has equal interval. So I'm not explaining all this, it will take time. But there are 4 types of scale, nominal and the ordinal. Nominal and ordinal are the scale on which you will be collecting the qualitative data. And this interval scale and ratio scale are the scale on which you will be collecting the quantitative data. But even though it is ordinal scale, qualitative data, you can convert into interval scale by assigning the values. Suppose you have collected on a scale strongly agree, disagree, and some strongly agree, somewhat agree, neutral, somewhat disagree, strongly disagree on this scale. This is ordinal scale, like a scale. So after assigning the values, you strongly agree for positive statement 5, then 5, 4, 3, 2, 1. Then when you assign this value, then it is converted into interval scale. Then there you can apply the parametric statistics. So how to convert? There is a system, you can convert it. Remember one thing, if your data are purely qualitative, you can't go for testing the hypothesis. Hypothesis testing is applicable only for those data which are expressed in quantitative terms. If the data are purely qualitative, no room for testing the hypothesis. But some data we convert into interval scale, then we apply the hypothesis testing. Remember one thing, qualitative data, you can't apply testing of hypothesis. But if your qualitative data can be converted into quantitative data, then there is room for testing hypothesis. So this is all about a scale of measurement. Yeah. So if we are doing parametric, so one sample test, there is a normal assumption is required, independent sample t-test, normality is there should not be any outlier. So, but when after collecting the data, when I test it, so there is no normal distribution. Then instead of discarding the data, you can apply non-parametric equivalent. One sample t-test is equivalent to one sample with Wilcoxon sign rank test. An independent sample t-test is equivalent to Mann-Whitney U-test. And the pair sample t-test is equal to pair sample Wilcoxon sign test. Here, there is no need for assuming that data exhibits normal distribution. And this you can do here, but many people do not go for non-parametric. Why? These are they call it less powerful. So less sophisticated, less powerful, not so they call it less powerful. So they don't go for this non-parametric. But instead of throwing away the data, you can at the most you can analyze the data with equivalent non-parametric. Yeah, there is no need for assumption of normality. But remember one thing: non-parametric statistics are not being often used by the statisticians, saying that they are less powerful. But at the most, instead of throwing out data, you can do this and then another way. I'm telling you another way. So one way is we can go for non-parametric equivalence. Instead of abandoning the data, you can go there. Another way, how to manage the normality. So in one session, you might have done transformation. You transform the data into logarithmic, square root, or reciprocal. Or manipulation means treatment. Here, manipulation doesn't mean you are doing wrong thing. You are doing herafiri. No, manipulation means you can do some sort of treatment to some sort of minor treatment to collect the data so that normality is being manifest. So let me show you now. In the transformation, logarithmic transformation, log x to the base 10 or natural logarithm x can be used for, and this will solve the problem of positive skewness, variance heterogeneity. Outlier problem can be solved if your data is being transformed by using the log x. So as I've shown to you that there is transformation. One technique is the transformation. You can and it might have been done today or yesterday or at the beginning. You might have done. You might have attended classes on transformation. So you can transform using the square root x. Then this will solve the problem of positive skewness, variance. This can be solved. And reciprocal treatment 1 by x. If you transform your data by 1 by x, this problem will also. But we have to take a question. It is not applicable for negative value of x and 0, and it is not applicable for negative value, and it is not applicable for x value equal to 0. Now suppose you have negative value, maximum negative value of -9, then you can convert it to positive. To all the data you add this one plus 10, or exactly you add plus 9, then minimum value you will get will be 0. So it says value of x less than 0, not applicable. Suppose you have -9 there, -9 is there, -8 is there. So in all the data you add plus 9. So minimum value you will get will be 0. So then you can apply. Then you can apply this square root transformation. So by adding, subtracting something, by treatment of the data, you can transform the data. Then again, and if they fulfill the normality and the outlier and then variance, then still you can apply the parameter. Parameter. Yeah. So if normality assumption is not being fulfilled, you transform it. Or one way, you use a non-parametric data. The second one, manipulation. Manipulation means data treatment. So here I have said manipulation means data treatment, not the wrong way. Sometimes we think that manipulation means herafiri. No, manipulation means some minor treatment is being done to the data. Winsorization, data trimming, data dropping. So winsorization means the assumption that outliers are present due to human error. We assume that, okay, these errors are because of human error during the data collection. The outliers on the upper side is replaced by adding 1 to the nearest non-outlier score. If you have one data outlier far away from the group, then you can replace this one by a number. The number should be from the existing group, that group up to what you have accepted. You add 1. So up to 34 you have accepted in the group. So you add 1 more, 34 plus 1, 35. So 35 will substitute the high score of something 70. Like this. So you take time to explain it, but I will not explain here too much. So those outlier problem can be solved by adding 1 from the larger and by subtracting 1 from the lower. So suppose if your lower acceptable point is -9, but you have -50. So -50 is outlier. Then what to do? your acceptable was up to -20, suppose, then you subtract it, -20, -1, so -21. This -21 will substitute your -50, and then you can assume that your data is normal. So in case of data trimming, what happens is that if we suppose right is skewed, so those in the right is skewed will indicate that your outliers are in the right side. So those data on the right side which are outlier, suppose there are 9 items, you remove 9 items from the right side. Then simultaneously you also remove 9 items from the lower side. So your data group will be reduced, but still the remaining from the remaining data you can have normality. And the other one is you just drop those outliers. Simply you just forget about those outliers, just drop it, and you continue. This is one. So these references I'm giving you, my dear friend. See, these are the reference. George D. Mallory, 2010, Spss for Windows Step by Step, a simple guide and reference, Boston and Pearson publication at Boston. And this is from the internet. And the Snakedoor, GW, and Koharan, 1968 publication, and then Indian edition by IBS publication. So these are the reference. And thank you very much, Dipjyoti. Over to Dipjyoti.
Thank you, sir. Thank you. So if there is any queries from the participant side, you can just ask sir directly, or also you can use the chat box. Mr. Dignesh raised hand. So if you have any question, you can directly ask.
Or you can run in chat box, no problem.
Okay. Sir, I have one question.
Yeah, please ask.
This is for my PhD purpose. I am comparing the data with the expectation of the students and satisfaction of the students. I have collected in my questionnaire Likert scale 1 to 5, expectation 1 to 5, satisfaction 1 to 5. So how can I use paid t-test?
Please repeat once. You have collected data on satisfaction.
Yes, sir.
So what exactly you want to do after collecting the satisfaction data? What exactly you want to do?
I just want to compare the expectation is higher or satisfaction is higher.
Expectation and the
Satisfaction. That is performance of the university.
one is expectation and one is collected. One is expectation. Another is what you have collected from the
Collecting from the students. Expectation, what they are expecting from university, and how university is performing.
You have measured twice. One is expectation.
Yes.
Then what is the
What is expectation of the students, and what is the performance of the university? That is satisfaction of the students.
So you can compare it, you can use it. Suppose there is no need treatment like after attending the classes of 1 year. So since you don't mention that clause, since you are not mentioning that clause, you can apply the 2 sample tests. So total score of, you have collected the data on Likert scale, right? Likert
Yes,
scale.
sir. Yes, sir.
So you have converted into, you have assigned the value 5, 4, 3, 2, 1 for positive statement, and then for negative statement should be strongly agree should be 1, 4, 5. For positive statement, if it is strongly agree, you should award 5. Then like
Yes.
5, 4, 3, 2, 1.
5, 4,
For
3. Yes.
negative statement, it should start with 1. Okay. Then Mr. A score how many? Then Mr. B score how many? So you are having two column. One is expected score, another is
Actual satisfaction score.
you call now you have converted into that ordinal scale. You converted into interval scale.
Okay.
By assigning interval, now you can apply 2 sample tests, or you can apply even other tests also. You can apply. You can apply the correlation R and then go for t-testing also.
Okay.
So that ordinal scale has to be converted into interval scale. Otherwise, you can apply parametric statistics.
Got it. Thank you, sir. Thank you.
Any more queries, please? Any more queries? Dr. Niladri, you want to
Yes, sir. Am I audible, sir?
Yes, audible.
Okay, sir. I just want to ask that if the data is qualitative data and I want to convert it, that is the categorical data, that satisfaction or satisfied or dissatisfied categorical data, then how can I convert it into the ratio scale or interval scale?
Nini, see, until you see, on which scale you collected data? You look at the variable of interest. Your variable, your interest variable should be continuous data. Continuous, it should be continuous variable.
Okay.
And then you are talking about a category that will become they will become the independent variable. The dependent variable should be continuous.
Okay.
Should be continuous. And again, your independent variable like male, female, there is dependent variable.
Yes,
but you will be analyzing on what? Satisfaction.
Yes, sir. Satisfaction.
Then how you have collected the satisfaction? On which scale?
Yeah, it will be collected with the help of the rating scale or the ordinal scale 1, 2, 3, 4, 5.
So either you can if you use nominal scale, yes, no. Are you satisfied? Yes, no. Then there is called nominal scaling. There you can't apply. There you can't apply the t-testing. Clear?
Okay.
But if it is ordinal scale, then as I've just mentioned that in the ordinal scale, your category are being arranged in an order. Now, suppose strongly satisfied, somewhat satisfied, neutral, somewhat dissatisfied. Then statement was positive statement. Then strongly agree is being assigned 5. 4, 3, 2, 1. Negative statement 1, 2, 3, 4, 5, 1. So Mr. A score how many? Suppose if you have made 5 statements, in that 5 statement, Mr. A score how many? In that 5 statement, Mr. B score how many? In that way, you can compile the score. After scoring, then you can analyze it. But remember, regarding your category male, female, these are dependent variable, independent variable, male, female. So, if is there any difference in the satisfaction among the gender, male, female? Is there any difference in the satisfaction among the urban teachers and rural teachers? So there you are using categorical data, right? The discrete variable. So these are independent variable.
Okay, sir.
So two type of variable, continuous variable and discontinuous variable. Always your variable of analysis should be continuous.
Okay, sir.
So you want to analyze job satisfaction, continuous variable. You want to analyze adaptation, continuous variable. You want to analyze yield of the crop, continuous variable. So what you want to analyze, and then you want to analyze whether this yield of the crop differ from place to place, or whether this performance differ from male to female, boy to girl. So those are the independent variable.
Okay, sir. Sir, do you able to get your PPT, sir?
PPT?
Yes, sir.
I'll give you the reading material, detail of what I have covered, because I have written in short. So detailed explanation I'll give you.
Okay, sir. Thank you.
Any more queries?
My dear friend, I tried my level base. I had little knowledge about this, and whatever little thing I know, I have compiled. See, I have asked, I have even asked my research scholar, and then I have asked my colleague, even some senior people are also there. Then I have attended some classes also. So after compiling all those, what has something covered in one training program, something not covered in another training program. So after compiling all, I try my level best to deliver to you. And this is not only from one book, from many books, from many training programs, and by consultation with many teachers. So I have jotted down together so that my t-testing should be meaningful in using it. Thank you.
It was excellent session, sir. It was excellent.
I try my level best. Thank you.
Dr. Vijay Kumar is there? Dr. Vijay Kumar?
One can ask a question.
Harshita, madam, please ask the question that you want. Yeah.
Yes, please.
So actually, I'm writing a paper. Sir, am I audible?
Audible.
Hello.
Audible.
So I'm writing a paper on interest rate fluctuation.
Interest rate fluctuation.
I'm writing a paper on interest. Yes, sir. So we have different types of interest rate like cash credit, term loan, deposit loan.
Yes.
So I'm testing the interest rate before the COVID and after COVID, like pre-COVID and post-COVID. So I'm planning to use paired sample t-test.
See, one thing, let me tell you one thing. If the data is quantitative, two things
Yes,
can
sir,
be
it's
done. Two things can be done. One is
Yes,
correlation
sir.
analysis. One is measuring the difference in the means. So t-testing, z-test,
Okay.
let me remind one thing. Whatever data we have, if it is quantitative data, two things can be done. Comparing the means
Yes, sir, it's
and comparing the
Okay.
means, correlation analysis. Correlation analysis, correlation. It may be multiple correlation.
Okay.
So whatever the rate fluctuation there, you have to calculate the mean first. If you want to apply t-testing, z-testing, and then this f-testing applicable to mean only, arithmetic mean. They are comparing the means among the samples, among the groups only. Even if you are using the percentage of fluctuation, so you have to go for certain arithmetic mean. Arithmetic mean of fluctuation during this period, or arithmetic mean of fluctuation during this period. Then you have to compare. Now, other things cannot be done except comparison of the mean, or other things cannot be done except you find correlation. You have to go for correlation R. So only two things. Please remember in mind. For quantitative data, you have to do things in your mind: either to compare the means or to go for correlation R.
Sir, can't we go for paired sample t-test?
Where sample t-test can be done, but there should be two periods of fluctuation. In the first period, the fluctuation
Yes,
of the
sir, it is pre-COVID and post-COVID.
okay.
Before the COVID and after COVID.
Okay. Before the COVID, there is a certain rate of interest are fluctuating. So find the arithmetic mean or data, the fluctuation.
So my question is, we have three types of interest rate. One is cash credit, term loan, and deposit for deposit.
Okay.
So for cash credit, there is no fluctuation. The distribution is not normal.
Okay.
For other two, the distribution is normal. So
Okay.
how to use the test? Because I have to use the same test for all the three interest rates.
Okay. So
What can we?
you say that the particular variables having normal distribution, others are not having normal distribution? You just mentioned
So
that.
only for cash credit, there is no normal distribution. For other two, there is a normal distribution.
That is, I'm telling you that for normal distribution, you can apply the t-testing. For non-normal distribution, equivalent non-parametric test is there. But if you want to use normal distribution, go for transformation.
Okay, fine, sir.
The transformation can be done by your square root x, log, or reciprocal.
Okay, fine. Thank you.
Whatever the rate fluctuation there, you have to convert them into any. You have to think in your mind that I am comparing the means only. So the t-testing will give you the comparison in mean, even though you have done the percentage rate of fluctuation, but the analysis will give you the mean of that particular period, fluctuation period. I don't know whether I was able to, I don't know whether I've understood your question, or I don't know whether I was able to explain your question. I don't know. Okay.
Sir, number
No,
of
sir, it was clear, sir. Thank you.
Number
Yes,
of
sir, thank you.
questions are coming in the chat box, sir. Vicky Sharma ji, you want to speak something?
Yes, sir. Yes, sir.
Please.
Sir, I have no question, but I love to be sit with entire session, sir. And I love to be like how we just use the testing. I have no idea before this session, sir, how we use it. But the entire your session, I love and I learn to be how we use this kind of tests. Thank you so much, sir. This is very systematic and detailed in nature, sir.
Thank you,
Very
my
systematic.
let me tell you one thing. If I made a mistake in identifying the problem topic in the selection of the topic, the rest will be wrong. From beginning, from the identification of the topic, then everything comes in a sequential manner. First, when you identify the topic, variable of interest should be clearly defined in the topic. Then, after in the definition, you should indicate the population of study. So, suppose job satisfaction in Assam, or job like this, a study on job satisfaction of the teachers among the colleges, among the degree colleges of Assam. That means this restricts that your study will confine in Assam only. So likewise, and you'll be studying the job satisfaction. Your variable interest is job satisfaction, and your population of study will be in Assam. So when you make the title, three things indicates. One is variable of interest, and another is population of study, another is whether your is going to be survey study or experimental study, type of research approach. Three things come to know. You will come to know. Then again, in the probability, again in the sampling, if it is not probability sampling, you can't go for testing. One thing. Again, even though it is a probability sampling, if the data are totally qualitative, you can't apply hypothesis testing. But if those qualitative data can be converted into intervals, into quantitative data, then you can only go for hypothesis testing. Then again, if your sampling is non-probability sampling, you can't go for hypothesis testing, because hypothesis testing is for generalization, and if you have done your non-probability sampling, your finding is true only for that sample size. My sample size is 300 using non-probability sampling, and then my finding will be true for that 300 only. It can't be generalized. Thank you. Thank you.
Thank you so much, sir. Valuable input, sir. Thank you.
Dr. Vijay Kumar, are you there? Dr. Vijay Kumar?
Good afternoon, sir.
Yeah, please give the vote of thanks.
Sir, I have just one question, if you allow me, sir.
Yes,
Yep.
please. Yes.
Sir, I am on performance of central cooperative banking in area now. In that, I have one objective to study the pattern of the loan portfolio with respect to short term and further categorize into agriculture versus non-agriculture, sir. So can I apply, sir, t-test for that?
Need for applying the t-test, I have already told you, t-test is mainly mean for finding the correlation as well as for t-test is mainly for comparing the mean maybe between two samples, maybe between two period, maybe comparison of the mean of performance between rural urban. So it mainly focus on comparing the mean of performance, mean. So if you want to compare between rural and urban, then you can apply it. Then if your objective is to compare, then you can apply. Otherwise, you can't apply it.
Sir, my objective is comparing the agriculture loan versus non-agriculture loan, sir.
Agricultural loan, so you have to, you can't say agricultural loan here. Mean of what? Disbursed by the bank. Disbursed by the bank.
Yes, sir. Yes, sir.
So, mean of the bank, mean amount of the loan, disbursed by the bank for agriculture, for particular sector during the period is suppose X1. Then mean amount of the loan disbursed by the bank to that sector during the particular period is X2. So X1, so you can find the comparison X1 minus X2 bar. So you can apply t-testing. So here you can apply two sample t-tests, independent sample t-tests you can apply it. But if it is more than two group, you have to go for F-test. For two.
Oh, okay, sir. Okay, thank you, sir.
Thank you very much.
Vijay Kumar, sir. Dr. Vijay Kumar. You are not audible. Hello, Vijay Kumar, sir, are you there? Dr. A. Vijay Kumar.
Almost 2:30.
So, can we proceed to Dr. Krishna Sudhir? He's not there, I guess. Lokesh ji, are you there? Lokesh ji?
Sir, I'm there, sir.
Yeah, please give the vote of thanks to sir.
So thank you, Deep Jyoti sir. It's a great privilege for me to give vote of thanks now. Sir, first of all, I would like to thank you for giving overall, throwing us the overall information on the parametric test and also explaining it in detail. And we got some kind of information and the practical things we need to apply. And then it is very good session. And on behalf being a participant, I have learned a lot of things and a lot of information is given in hand. Thank you very much for your wonderful session, sir. We got a lot of learning from this session, and I thank Deep Jyoti sir also for giving me this wonderful opportunity. Thank you very much, sir.
Thank you. Namaste.
Thank you. Thank you, sir. So we are here. We are coming to the end of this session, and we are proceeding towards lunch. We'll meet up again at 3 p.m. So thank you.
Thank you.